Okay, so hello everyone. I'm here with Vasco Grilo. Vasco, thanks for coming on the podcast / YouTube channel.
Yeah.
So Vasco, for people who don't know who you are, who are you?
Okay. Who am I? So yeah, I basically studied engineering, finished my studies 2021. I've always been interested in numbers, and at least my journey in effective altruism was more or less like initially trying to figure out which cause is the best. Initially, I was deferring a lot to 80,000 hours. So I more or less trusted the arguments presented in the precipice and then worked that alliance to feed the earth in disasters for a bit. Um, However, I did not really like investigate the arguments deeply enough. And when I did, I found out or concluded that existential risk, or at least risk of extinction, is way lower than presented by Tobiard in the precipice, at least in my opinion. And I also have doubts that just even if the risk was like 1 in 6 over the next 100 years, as Toby mentions, I don't think that necessarily implies prioritizing, increasing the value of the future, because there's still a question of tractability. So started shifting more towards near-termist causes, namely animal welfare, because it looked like we could improve the lives of way more animals per dollar than the number of humans per dollar, even after adjusting for differences in capacity to experience welfare. So that eventually led me to like prioritizing increasingly small animals. Because we can basically affect more animals per dollar if we go to smaller animals. This is just because there are like way more smaller animals in the world, like 10 to the power of 20 or 21 or 22 nematodes versus just 10 to the power of 10 humans, 10 to the power of 10, 1 followed by 10 zeros. Now why were we here talking? Matthew invited me. I like Matthew's posts quite a bit. Also sympathize with Matthew's willingness to just say what he thinks on the blog, even if it can potentially be controversial. I also do that sometimes, very rarely, but sometimes.
Yeah, so I
Yeah,
I sh- so I like your posts as well. I think they're quite an interesting contribution. Um,
thanks.
so I guess there's a joke where it's like people say it, sort of like if you're less utilitarian than them,
Mm-hmm.
then you're kind of like a naive fool. But if you're more utilitarian than them, well, then you're sort of a crazy person. So I think we may have
Yeah.
found the guy who's more utilitarian than I am, who is writing these many posts about the impact on like bacteria and soil nematodes and so on. And that's even for I'm sort of sympathetic to caring about soil nematodes, but I have not like
Uh-huh.
written extensively or done extensive deep dives into the impact
Mm-hmm.
of various things on soil nematodes. Um,
Mm-hmm.
but so I guess so what the reason I wanted to have a chat was I thought my sense is your view is sort of like the ethical impact of our actions is dominated by in expectation by what happens with respect to very small simple animals. And I
Yeah.
don't think that's right. I think that that's one of many
Mm-hmm.
important cause areas, but I don't think that it's the one
Yeah.
that gets sort of like lexical priority. So my basic
Yeah.
so as far as I can see, the basic argument for caring about like uh soil nematodes, well, the
Mm-hmm.
argument for caring about arthropods, I think, is much more straightforward. It's like it just seems like arthropods are probably conscious, at least
Mm-hmm.
around 50%. And so if they're just like
Mm-hmm.
hundreds of millions of arthropods for every person, and
Mm-hmm.
these arthropods, it seems plausible that they can suffer, and we don't
Mm-hmm.
have really good reason to think they only suffer a little bit.
Yeah.
Um, then it seems to make sense to care about arthropods a lot. And I
Yeah. That
buy
makes
that.
sense.
That's one of the reasons I give to global health charities. I think it's
Mm-hmm.
good for animals. It lowers arthropod populations.
Mm-hmm. Yeah.
But then you get sort of like to lower probability things. So then you start talking about soil nematodes. These are creatures often with only like a few hundred neurons. Then you start talking even about microorganisms like bacteria and yeast. And you're like, look, these guys probably aren't conscious, but it's like there are, you need a really big exponent to write out how many of them there are. And so it ends up getting pretty absurd. And so that's the sort of core idea behind it having a lot of expected value. And then you do these sort of rough Fermi estimates, and then it's like, what? You're affecting billions of years of nematode life per dollar in expectation? Like, what? That's insane.
Can I just like make a short comment on that? Like, so just like when we comment is that I think like sometimes people like immediately jump to the nematodes. I guess that's because it's like more salient or unusual to talk about. But it's worth noting that even if you set like the welfare of nematodes, mites, and springtails, which are the arthropods that exist in the soil that are most abundant, even if you set the welfare of all of those to exactly 0, and you just consider like ants and termites, which have around the same number of neurons as shrimp, then the welfare of soil animals still like dominates by many orders of magnitude the welfare of farmed animals. At least if you trust something like reefing priorities moral weights. And reefing priorities moral weights, or like the weights that Bob Fisher, who led the reefing priorities moral weight project, he has a book, and then he has a table with some estimates. And if you trust those estimates and apply them to ants and termites, which are still within the range of, I would say, applicability of those, you still get that soil animals dominate. So it's not as if you have to like trust me that nematodes still matter a bit. I do think that we should not like discount nematodes, mites, and springtails. But even if you discount them completely, I think one, total welfare of soil animals still way larger than that of farmed animals, and two, even things like cage-free campaigns, broiler welfare campaigns, I think their expected effects on soil ants and termites still dominate in expectation the effects on chickens, if you trust something like reefing priorities moral weights. So that's just like important background. I don't think the problem goes away if you set aside the bacteria and stuff.
I am like pretty sold on that. The impact that our actions have and expectation on arthropods just like dwarfs the first order effects of them on certainly on people, and even of like things that affect arthropods in sort of random ways. It ends up looking like if you take arthropods seriously, like giving to give well might even just like be the best for or it might be that human charities end up being better for wild animals if you think they mostly have negative lives than giving to animals.
And if you discount nematodes, I guess, because the effects on nematodes can be different from the ones on arthropods. But
right. It gets weirder when you take into account nematodes, because it's not clear. Right, you were saying it's actually not clear if humans reduce nematode populations.
Yeah, exactly.
It's clear that they reduce arthropod populations. But so I guess here's why I feel like I don't go full Vasco. Okay, I don't think that it's the impact on nematodes and simple microorganisms that dominate. So I think that it's true that there are scenarios by which, with fairly low probabilities, by which it might be that that our impact on arthropods and nematodes, unlike nematodes
and microorganisms,
ends up just dwarfing the impact of our actions on other on larger animals, even if we give fairly low weight to, even if we assign fairly low probability to them being sentient and give them pretty low welfare ranges conditional on sentience. But I think once you start taking into account low probabilities, like these really low probabilities, there end up just being a lot of them. And I worry that I think it's wrong to focus primarily on the nematode ones and ignore lots of other ways by which our actions could turn out to be really good in all sorts of other ways. So let me just discuss 3 categories of these ways. The first one is here. So there's a thesis that Dustin Crummett has provided some arguments.
I just have like one question, but maybe I should not interrupt so many times.
No, go ahead.
Okay, it's just like I was curious, like why do you start wondering these other hypotheses, low probability hypotheses, after specifically arthropods and not say after shrimp or after cows? Because some people say that cows, it's kind of rare, and I think against scientific consensus, but maybe after shrimp or somewhere between shrimp and cows, the probability is already so low that it's already kind of Pascal's wager territory. So I wonder, like, why after arthropods for you?
I guess I think that it's like I think of it as there being a difference between actions where you have a high probability of doing lots of good and actions where it's just like it's like the scenario by which it would turn out good is very, very low probability, but it's just it has so much potential value that if it turned out that way, it would be good. So it's like and I think the odds that arthropods suffer, I think, are pretty good, near 50%. So my thought is like the nematode conclusion is more like other conclusions that are low probability where things turn out to have extreme weights, rather than one where they just have intermediate weights. Now, I think, maybe if I were a better utilitarian, I would just multiply the probability times the magnitude very consistently, and then I'd sort of like maybe just be focused on almost exclusively on really low probability events. But I guess just it's a fact about my psychology that I find it hard to be motivated to do that. And it's certainly very hard. I have a blog, and it's like it's hard to convince other people to do that. It's like it's a much easier sell to be like, you're reducing, you're preventing, tens of thousands of shrimp from suffering intensely per dollar. That's a much easier sell than you're in reducing the probability by a tiny amount that it's like these beings probably don't suffer, however, like 1 in 1,000 chance of suffering. In expectation, you're like maybe reducing the likelihood of them of the soil
existing and suffering, or something like that.
And I also
1 in 1,000 seems low though, but
and I do
1 in
think
1,000.
Or sorry, good.
Go ahead. 1 in 1,000 seems low to me if you are at like 50% for say arthropods, and so you drop like by a factor of 2 from humans to arthropods, and the number of neurons drops by like 6 orders of magnitude. Say shrimp have 10 to the power of -6 as many neurons as humans, and then maybe you drop like a factor of 2, and then you drop a factor of like 100 from shrimps to nematodes, even though it's just like 1 or 2 orders of magnitude. It seems like very weird that right after shrimp, the probability of sentience goes down way faster.
I don't know. It's like you can, like 100,000 neurons is the point at which they're like doing, like at that point they're like doing sort of complicated things. If they have like 100 neurons, even though the number of orders of magnitude difference isn't that great, it seems like there's a pretty big categorical difference. But sorry, so with respect to the few points, and just I think once you buy that there are more things on heaven and earth than improving the welfare of wild nematodes in the near term, then it begins to look like spreading the right sorts of values that are compassionate and care about other animals is really important. And I think like that's a harder sell if you're like, okay, care about the welfare of animals, and if you do that, just spend all your time trying to improve the welfare of these like microscopic worms. But so sorry. So let me just describe the three thing. So and this is not an exhaustive list of kind of like muggings that I take seriously. So one of them is now I'm forgetting what the third one was. So one of them is just like long-termism stuff. The long-term future could contain extremely large numbers of people. In particular, I think the long-term future could contain, like, it could be that in the far future, we figure out really simple ways of improving welfare by a lot. It could even be that we figure out simple ways of creating infinite happy universes, or that we increase the human population or increase the population of sentient beings, and then theism's true, so they end up making it to heaven. And so this seems like it has maybe infinite expected value, because the scenario, there's some chance of it going well. And so then this ends up just, outweighing the soil nematode one. Here's another sort of related scenario. So it might be that that every subset of a brain that's individually sufficient to produce consciousness produces its own consciousness. So like consider any particular neuron in my brain and then think about if we remove that neuron from the brain, my brain would still be conscious. So then on this view, you think, well, then my brain minus that neuron is conscious. And if you have a view like this, maybe you get infinite conscious subsystems. But even if you put that aside, if you just do it in terms of neurons, you get at least, in the case of creatures with n neurons, you get 2 to the n neurons. You get 2 to the n conscious subsystems where n is the number of neurons. So then you end up having one human having more conscious subsystems than all soil nematodes. You end up with one elephant having more conscious subsystems than all humans. And so then it's just like whichever creature, whichever individual on Earth has the biggest brain, that's like where nearly all the welfare matter lies. There's also ways it like maybe like, you know, maybe theism's true, and so then spreading and so then convincing people the right religion spares them from hell, and that prevents them from spending infinite years. It's just like once you start taking into account these scenarios by which things might have really enormous expected values, it's like it's not just that nematodes might matter a lot; it's that a lot of different things might matter a lot. And then my conclusion from this is sort of like, if you think that there are all sorts of things that might be astronomically important that we're kind of in the dark about, the thing it makes most sense to do is first try to like do research and think rigorously about what the most important topics are, and second try to steer the human species so that they're in a place where they're both optimally morally aligned and in a position to bring about these. So then I think you end up with a much more long-termist conclusion where it's like, you know, in the far future, like it's more important that we try to get to a future where we can figure out what the welfare ranges are, or what things are astronomically important. So that's sort of my basic thesis of why I don't take the Vasco train all the way to the west.
All the way to the Nematodes. I see. Let's see, what are my thoughts on it. So, like with respect to this low probability scenarios that you mentioned, like if I think about the probability of these actually holding, I think all are way less likely than, say, nematodes being sentient. I would say nematodes being sentient is at least like 1%. I would go as far as say more than 10%, but whereas like say subsets of neurons being people, we are talking about we add one neuron to a person and this doubles their welfare. That definitely seems way less likely than say 10% to me. Theism, if it's like, depends on what you mean by theism, but if you are thinking like someone dies and then there's an infinite life after death, I would also say that's way less likely than 1%. And what's the other future scenarios? The far future can be large, but then there's this question of, okay, like we decrease extinction risk this century by 0.001 percentage points. Where does this probability mass go? Does it go to, we don't go extinct by 2100, but we go extinct 1 year later? Or is it that we go extinct, or our descendants go extinct like millions of years into the future? And I would say like that the fraction of the probability mass that lives this century and goes to the astronomically valuable worlds is also way less than things like 10% or 1% of the probability mass which lives this century. So to me, it doesn't feel like we are in the same ballpark. I feel like the nematode stuff is still like way closer to the arthropod stuff. Like I would say that the probability of sentience is probably it will not change too much with the number of neurons or number of behaviors that nematodes perform as a fraction of those of humans. And like if we base the probability of sentience or the expected welfare per animal year on these proxies, either behavioral or anatomical, I think the probabilities of sentience will not vary a lot. Whereas with these scenarios, I feel like they are many orders of magnitude lower. I can argue for why I think these are way less likely. But yeah, any thoughts on this?
Yeah, so I guess I think so I agree that a lot of these are lower probability than nematodes being conscious. Like but I don't know that for some of them. I don't know that they're well. Actually, I think theism is high probability, but I think conditional on theism. I think mostly, most likely, whether or not our soul gets created doesn't depend on whether or not we're brought into existence on Earth, and so conditional on that. I think I think theism at least makes it a lot murkier. Whether I think the kind of theism that leads to these kinds of fanatical results, I agree, it's lower probability. But one has to compare the lower probability to the massive increase in value, right? So it's like 2 to the power of 86 billion is way more than 10 to the power of 20th. 10 to the 20th is 0, basically, compared to 2 to the power of 86 billion.
Yeah, that's true.
And so if you're being a good utilitarian, where you're just multiplying the probability by the value, well, then it seems like these things will dominate, even if you think the probability is 1 in a billion of a lot of them, 1 in 10 billion. Now maybe your idea is like, well, you kind of discount low probabilities.
No. We should not discount.
Okay, we're in agreement. Yeah. But so and the other thing to say is, so regarding the far future flourishing stuff. So I agree that you as an individual will have your probability of impacting the far future of preventing extinction will be very low. As will my probability, any individual probability. But it's also the case that any individual will have limited aggregate impact on soil nematodes. It's like their impact on the global distribution of soil nematode suffering will be very small. And so I think what you want to compare is like the probability of making an impact by how much the impact would be. And so then I think it's like, if you want to compare the probability that, say, humans as a whole majorly impact soil nematode welfare, because soil nematodes have welfare, to the probability that humans as a whole, like what we do now, majorly impacts existential risks. Then I think that what we do now majorly impacts how the far future goes. That strikes me as quite plausible. In fact, like I'd be at certainly double digits on that hypothesis.
Let's see. So with respect to the, actually, like, first let me just take 10 seconds to connect my computer to the electricity grid. Okay, technical stop. Yeah, I'm good. Let's see. So basically, like, with respect to influencing the far future, I was not super clear about it, but the way I think about it is like, how fast do the counterfactual effects decrease across time? So if we have, like, for example, an RCT, we can try to measure differences between intervention and control group, and then see how those differences evolve across time. And then we can adjust for noise, because like, the difference that we observe at any time can be due to just random factors as opposed to our intervention, and we want to know our causal effects, so we have to make some adjustment. And there's like a report / investigation from, I think, David Bernard, who was at Rethink Priorities 2 years ago, and he basically looked into development economics RCTs ranging from like 1 year length to 20 years, and basically tried to see like how fast do the effects decrease across time. And I think it depends a lot on the assumptions, but it was at most like a few hundred years. So I think, like, basically, like, when we try to think, can we affect the far future, we should have some rigorous empirical method of assessing it, as opposed to just guessing things like, it seems like we can influence the far future. Slavery seemed contingent, which is kind of the analysis that are done in What We Owe to the Future. I think, we should. I think the best way to analyze causation is RCTs. So I think that's a good place to start. And that analysis finds that effects more or less become negligible after hundreds of years. And I would say this is probably still overestimating how much the effects last. I can explain why, but like I guess like one important thing is that this hundreds of years is basically for a growth rate of like 3% per year. And I suspect that the larger the growth rate, the faster the effects will decrease because there's more stuff happening. And because I think like one argument that long-termists make is that, oh, the future like can be influenced a lot because we will have transformative AI soon. But for me, the time horizon of the prediction is not necessarily the crucial variable for assessing how difficult it is to influence the future. I think a better variable would be something more like ratio between GDP then and GDP now, because the faster the annual economic growth, I think the harder it is to predict changes. If we were like 300,000 years ago, everything was kind of static, nothing changed. So it's easier to make like, oh, like in 1,000 years, we will still have like these dances in the tribe. We will still be hunting or collecting berries because things were not changing fast. Whereas now, like making a prediction 1,000 years off, it is like, very hard. So those 500 years based on RCTs, I suspect that if the growth rate was more like 30% per year as opposed to 3% per year, that they would drop by a factor of 10 because 30% is 10 times 3%. So it would be more like instead of hundreds of years into the future, maybe you can predict at most a few decades.
Sorry, I'm not sure if I understand what
Yeah,
the
yeah.
RCT was measuring.
The RCT was just measuring like differences between control and treatment groups. So it could be deaths or incidence of prevalence of a certain disease or how much income do they have. Things that RCTs typically measure to assess global health interventions.
They were just saying that these interventions sort of wash out after 500 years.
Yeah, that's the extrapolation, adjusting for noise. This 500 years was the best guess in the analysis, but like depending on your assumptions, it can be like for some specifications it was 50 years, for other specifications it was like thousands of years. This depends on. Go ahead.
That strikes me as giving extremely weak evidence about how long-termist interventions would play out. The kinds of long-termist interventions, they're not like doing a global health intervention and then hoping that it continues making things better into the future, but rather they tend to have to do with, well, most of them have to do with trying to reduce existential risks. And certainly an existential risk, if it happens, will imperil the entire future.
I think like we should be careful here, but so I'm interrupting. Continue.
No, sorry, go ahead.
Okay, I think we should be careful here with how we like basically name concepts, because I think this at some point can become like a discussion about definitions. Of course, if we define existential risk as like impacting the long-term future, then by definition, if we decrease existential risk, we are impacting the long-term future. But then the question becomes, okay, like how likely is it that this concept is even a coherent one in the sense that we can affect the long-term future?
Sorry, I by an existential risk, I mean a risk that might kill everyone.
Okay, so extinction risk.
Yeah.
If you mean kill all humans, then it would be extinction risk. Okay, so then the question is like basically that's a claim that if we decrease the probability that all humans die by a certain date, we will increase the probability that we will have 10 to the power of 50 lives some point into the future. Because that's what's right. And the question is how you measured it.
Yeah, and just to give sort of like a very rough back of the envelope calculation. So like suppose you become an AI researcher. So there are about 1,000 AI researchers who are around. And let's say you think that you have the average impact of an AI researcher and that AI researchers that collectively risks of extinction from AI in the next century are 1 in 1,000, which I think is rather conservative. And then we think that all the AI researchers together will reduce extinction risks by 1 in 1,000, which that strikes me as even more conservative. I would guess the aggregate of AI alignment researchers to have a non-trivial impact on whatever the extinction risks are.
So then it would be like 10 to the power of -9 because it's 1 in 1,000 extinction risk, 1 in 1,000 all researchers together. So per researcher, 10 to the power of -9.
Which is I think 1 in a billion.
Yes.
Yeah, and so then even if you take into account just people today, well, you're saving 8 people. But if you take into account the far future stuff, then the expected value of that is maybe infinite.
Yeah.
Even if finite, it's if you buy the Bostrom if you think the Bostrom 10 to the power of 52 future alive estimate is good, then
So
it ends up being like 10 to the power of 30-ish.
yeah.
And the other thing is, I actually think I think the Bostrom,
40.
this is going to be a wild sounding claim, but I think that the Bostrom 10 to the power of 52 estimate is a radical, wild, extreme underestimate of the expected value of the future. For the following reason. I agree. It's
Estimation.
right. It might be an all right guess for how big the future might be. Like it may be that it's a good best guess or approximate, reasonable upper bound. But the point is simply that there are all sorts of unknowns in the future. Of unknown ways that we might just be able to impact staggeringly large amounts of value, right? So if you think there's a 1 in a quadrillion chance that of the subsets thing, well, in the future, if we figure that out, we can just make these massive brains with arbitrarily large value. If you think atom welfare matters, which I think once you start caring a lot about bacteria, it's probably atoms swamp that. Well, maybe we can figure out ways in the future of improving atom welfare. There might be able to be ways that we could make huge, infinite or very large multiverses in the future that contain mostly flourishing people. So once you sort of I think when you have just extreme uncertainty about a parameter, and it could be, and there are scenarios where it could be really enormous, then you should just think the expected value is really enormous. And that's how I feel about the future. So it looks like the expected value of being an alignment researcher is really, really high.
Okay. So my reaction to that is, I agree that in terms of the decrease in say extinction risk this century, 10 to the power of -9, I would personally put it few orders of magnitude lower, just because I think extinction risk from AI is still pretty low. Maybe this century, I don't know, 10 to the power of -7. So then it would be more 10 to the power of -13 or -14. But I don't think this is important for the discussion, in the sense that 10 to the power of -10 or -14 or -15 times 10 to the power of 50 is still a very big number. So in that sense, it wouldn't matter what the extinction risk is. First, I think this is kind of a red flag, because basically, even if the extinction risk from AI was, say, 10 to the power of -20 this century, that argument would still go through, which is kind of suspicious in some way.
Well, I don't know that it would go through. I mean, well, sorry, let me two points about that. First is it wouldn't go through relative to other ways to reduce existential risks. So then it would seem like working on bioterror or nuclear war would be better.
Yeah, I guess they are all correlated, so they would all then go down. Yeah.
Probably. Right. Sure. I guess. Right. If you think that the odds of existential risk this century are from all of these are 1 in 10 to the -7. But then the second point is it doesn't. I mean, if something, if it works out, is really valuable, then it might just be that it swamps everything, even if it has low probability. And I think you should be sympathetic to this, because I mean, just changing things on your calculations by a few orders of magnitude doesn't change something. If you ended up thinking the odds of soil microorganisms being conscious were 1 in 10 to the -9th rather than 1 in 10 to the -4th or whatever, that wouldn't really affect the overall numbers. It still comes out massive.
Well, at least according to my calculations, total welfare of nematodes is maybe 5 orders of magnitude the welfare of humans. So there's still some room for you to push the orders of magnitude up and down, or the probability of sentience. But it's not as if if there was, say, there are 10 to the power of 20 nematodes, but if there were 10 orders of magnitude fewer nematodes, it would be as many nematodes as humans. So then humans would clearly dominate.
Wait, sorry, you think soil nematodes only have 5 orders of magnitude more welfare than humans in expectation?
Maybe something like that. I would have to check my calculations. It depends a lot on the parameters. This is kind of a
okay.
guess. Yeah. But I would maybe not 5, maybe more 6. Not sure if that matters much, but yeah, in one post that I did about this, it was like 1 million times my best guess.
Yeah, I was
So
thinking
like
more
6.
about the like soil microorganisms.
Yeah, okay, that I'm more confused about, because I'm not like the estimates for nematodes. I basically rely on a power law of the number of neurons to do the comparison, in particular square root of the number of neurons. So like if 100 times as many neurons means 10 times as much welfare per animal year, but for bacteria it's harder because they do not have neurons. So I do not know how to make it like in a decently.
Right, but I mean, you can just get like here. Just this seems like a pretty conservative lower bound. It's like you think that bacteria have a 1 in a billion chance of being conscious, and conditional on being conscious have a welfare range of 1/1,000,000th what humans have.
Yeah, but these are like very. I don't like this kind of reasoning, because, and this was my criticism for basically coming up with this estimate, say, for existential risk, which is that people, like, once you get to the, say, 10 to the power of -9 decrease in extinction risk this century from an AI researcher, then this is not the probability that you will increase the futures of 10 to the power of 50 or 10 to the power of 100 lives. This is just a probability that all humans do not die this century is increased by 10 to the power of -9. But then there's the question of like, okay, like all humans do not die by 2100. But what if all humans die in 1 year later? Then that only means like 10 to the power of 10 more human years, right? So then like you need some additional modeling to translate the probability mass which leaves this century, 10 to the power of -9, how that probability mass is distributed across all the possible futures.
But I mean, that won't affect things by more than a few orders of magnitude at most. Like,
how do you know?
Well, so I think, so suppose that that AI alignment prevents us from going extinct this century. So my estimate was a conservative estimate, I think, of the probability that AI will that alignment
AI researcher will decrease the
probability will prevent us from going extinct this century. That any individual alignment researcher will prevent us from going extinct. Now, then we can ask a further question, which is, okay, conditional on them preventing us from going extinct this century.
Yeah, what happens?
What are the odds that we would have otherwise gotten the great, glorious post-human future where, stupidly large amounts of welfare? I don't know what the answer to that is, but that it doesn't strike me as extremely low. Like around 50% seems like maybe a reasonable guess, maybe 10% or something. But like in any case, I don't think it'll affect it by like, it wouldn't be like, well, conditional on us on an alignment researcher solving alignment and then preventing us from going extinct. The odds of this affecting whether we get to the glorious post-human future are like 1 in a quadrillion or whatever. Like I feel like it won't be enormous.
But like this is, for me, this is not obvious. Like for me, it's totally possible that it's like 10 to the power of -100.
But well,
because I don't have a good model. Like for me, it's like saying.
When you don't have a good model, you should not give extremely low values for things. Because you should have lots of uncertainty about them. So you shouldn't say, I'm extreme. Like in expectation, things that you're uncertain about, you should treat them as not being extremely low generally, unless there's some strong reason to think they're extremely low.
Yeah, I don't think I was describing my position correctly. So it's not only that I do not have a good model, but more that I have a model that the effects will decrease across time, because that's what happens, and across space, because that's what happens with all empirical phenomena that I'm aware of, basically. So, for example, if I have a pen in this room and I leave the room for 10 minutes and then I find the pen is not in this room or it's not on my table, I can ask, okay, like, where is the pen? And then I have some probability distribution across all the universe of the position of the pen. And if it was 10 minutes, it can be like 10-minute light, 10 minutes times speed of light, a sphere centered around the position of this pen, but which will be probably like millions of kilometers. But like clearly, it's way more likely that the pen is, I don't know, somewhere in the house or somewhere in the street than, say, on Mars. And when I think about, like, so this is about the mass of the pen. I should not just put the mass of the pen, like, distributed equally across all the universe. And likewise with, go ahead.
But I think you need to compare similar things. So it's true that it's like if there was any highly specific intervention, like, like I would expect the impact of, like, I don't know, a minimum wage increase on the economy to, in the long term, roughly wash out. But that's very different from the whether or not a thing that prevents us from going extinct will wash out. It's like you should be very wary about induction, where you start with randomized control trials about, like, health interventions and things along these lines, and then you carry this over to whether or not going extinct would have a long-term impact on how things play out.
Yeah, I'm not sure. Like, for me, it's not intuitive that there's a difference, because, like, let's say that you prevent extinction, or let's say a career change, for example, like, or a policy change. Like, if you put some policy, it can be an AI pause development, pausing development of advanced AI. Like, if you do not pause, presumably other things will happen in the world that will kind of cancel your effect. So maybe, like, there's some catastrophe, and that catastrophe is the thing. And the catastrophe does not immediately kill everyone, because in general, catastrophes, like lower severity catastrophes, happen way more often than high severity catastrophes. So then there will be some small catastrophe, and that will prompt a pause. So in effect, by, like, advocating for a pause, you are, like, speeding up the time at which the pause happens. But it's not as if without your action, like, you will have, like, infinite effect, or postpone the pause, or anticipate the pause by, like, infinity. And with extinction risk, I think, like, the same is true. So if you have some action, and in the worlds that you are going extinct, because of your action, you go extinct later. Like, the effect is not infinity. It's not like you either go extinct in 2100, or you go to the 10 to the power of 50 lives. There's, like, many intermediate outcomes, and it's much easier to make the outcomes which are closer to the baseline one more likely, than making more likely the outcomes which are very far away. In the same way that it's much easier to move the pen inside a house, or, like, nearby or to the street, than moving the pen to Mars. So, like, I should put way more probability mass nearby where the pen was. Likewise, I should put way more probability mass in humans going extinct, like, close to 2100, as opposed to 10 to the power of 50 lives.
I don't. So I agree, you should have some probability mass there. It's like you should think, like, you should, if you think, if we would have gone extinct immediately had you not taken an action, you should think there's some probability that, like, that reflects some deep underlying pathology where we will still go extinct even without you doing that.
I think that should be the.
But the question is whether we should think that that's near certain. So I guess here's my kind of, like, so I think if we think, look, an individual alignment researcher reduces existential risks by 1 in a billion this century, and then we think conditional on not going extinct conditional on them stopping us from going extinct this century, what are the odds that we would have otherwise gotten a really awesome future? I mean, I think the odds just by default of us getting a really awesome future aren't super high. I think, like, it's more likely that we'll get a kind of mediocre future, because I think humans mostly have not great values and aren't maximizing consequentialists. But I guess, like, this really doesn't seem like the sort of thing where, like, it's, in order to think this, what you have to think is you're extremely confident that conditional on, in order to think this affects things by many orders of magnitude, you have to think conditional on your action preventing extinction
by a certain date.
Yeah, by a century from now. That conditional on that, you're extremely confident, well above 99.999%. That
it will not
won't
increase the probability of
that won't, like, affect the long-term future of humanity. And I guess my thought is, well, if we go extinct, then the long-term future of humanity is bad. So in order to think that, then there is no long-term future of humanity. So in order to think that, what you have to think is that conditional on it being that if you prevent extinction, it's almost certain that pretty soon after the century we'd go extinct. So in the next 500 years or whatever, that it's highly likely that we'd go extinct.
Yeah,
and
that's my guess.
I
With
mean,
IS-180.
that seems like I don't want to, that seems like a crazy thing to be extremely confident in, north of 99.9% confident. It's like
I don't know. I feel like people have like some bias against very high or very low probabilities, because like when you say that, say it seems like very hard, I think you have in mind common events where probability ranges from like 1 to 99%, and there of course it is like completely crazy to say like 99.99999 or 0.0000. But if it's like an event like what happens with 10 to the power of 50, I don't think we should use our intuition at all. I feel like you are trying to use your intuition to then come up with a number, whereas I'm not using my intuition at all. I'm just thinking in terms of models. And if I think in terms of models, like probabilities like 10 to the power of minus 100 are very common. If you have like, what's the probability of having a human which has like without biological modifications, having an being say 1 galaxy tall. Yeah, if you have like some normal distribution with like 1.7 meters of age and some standard deviation of 15 centimeters, the probability of a galaxy tall is like 10 to the power of minus billions. So you can get probability. I'm not sure if it's billions, but it's like certainly way less than 10 to the power of minus 100. The point being that you can get probabilities which are very, very low, like much, much lower than 10 to the power of minus 100, once you have some model of the situation, as opposed to just being using your intuition. And I think
right,
the crucial. Go ahead.
In order to have a model like this, where you're like extremely confident that you have no effect from a model, what you need to think is you need to be extremely confident that the model is giving you accurate information about how things are. And I don't think a model from like health interventions. I think that's barely informative at all. I certainly don't think that it's the kind. It's like learning that health interventions tend to wash out in the long term. Should not affect your credence in the probability that humans would go extinct, conditional on a single person not preventing extinct. It shouldn't shift that by a factor of 1 billion. And I'm
not sure, like, because aren't health interventions basically like ultimately changing human population and decreasing the risk of extinction is basically like increasing human population. So I do see a parallel, but then it's not just health interventions. I think it's like anything that I do in the world. Like I drop a rock in the sea, like the waves are larger, closer where the rock is, and then they like tend to zero the oscillation. So it's not health interventions like temperature, you increase the temperature here, the temperature change in the air decreases with the distance to the source. Like any kind of change in the world, I feel like it dissipates.
But I think there's a special reason to think that extinction would be impactful. To think that existential risk reduction would be impactful beyond intervention. So it's like the effect of a small action. It's not surprising that washes out in the long term, whether it's an impact on temperature or health intervention, whichever of these things it is. But if we think that humans are a species that plausibly will impact the far future, that like we're sort of the most significant species on Earth, eradicating the most important drivers of the future. It's like, if you want to figure out if that will impact the far future, it just seems clearly wrong to do induction on that from like minor events like increasing the human population by 1. There's a very large difference between increasing the human population by 1, which does not have any broad, which like it will not broadly change how the future. It at least doesn't seem obvious that it'll broadly change how the future goes, because it's still, you have sort of like broadly the same type of forces active in geopolitical affairs. So changing the human population by some amount doesn't seem like that's odd.
But what we are doing with preventing extinction is changing the population from 0 by 2100 to above 0. So it's like, I guess that's one question also that I have is, why is preventing extinction dramatically different from saving a life? Like, presumably there's some value of saving one life, which depends on the population size. And what you are saying is that increasing population from 0 to 1 by 2100 is way more valuable than, say, increasing population from 8 billion to 8 billion plus 1 now this year, like why are there like 10 to the power of 10 or 10 to the power of 50 orders of magnitude of value of difference? Yeah, it's not clear to me because
I mean, there are some impacts on the human population that would, I think, really seriously imperil how the far future goes. So, like, one thing that if basically if there was a virus that infected everyone on Earth and killed off everyone outside of North Korea, I would find that I think that could plausibly impact the far future by quite a lot. It could plausibly, I don't know if there would be eternal dictatorship or if it would just set us back thousands of years, but like that could be very bad. The core idea is that there's lots of value at play if kind of like broad human aims are achieved. These broad human aims include like, spreading to the stars, things along these lines. Just by increasing the human population, it doesn't seem obvious what effect, if any, that would have on human aims. Maybe it'll affect it a little bit, but it doesn't seem obvious. And there are ways that it's beneficial and also ways that it's harmful. Overall, doesn't seem too obvious in either direction.
But why is that different? Like, why is there a difference from changing human population from 8 billion to 8 billion plus 1 and changing population from 0 to 1?
Well, the idea is that by changing, it's not from changing it from 0 to 1.
That's the easiest way of avoiding extinction, probably.
But I mean, one person can't reproduce, right?
Yeah. But like when the thing is, like, I think people are comparing like 8 billion with 0 people, but when you decrease extinction risk, like most of the probability mass will be in just postponing it because it's way easier. Say imagine that you are a human. Like, it's way easier to extend your life by. Say again?
Oh, I said easy to imagine.
Yeah, true. Like, basically, extending your life by 1 second is way easier than extending your life by like a factor of 10 to the power of 50. And that's what we are comparing, right? Like, we are extending human life, civilizational lifespan from, say, 100 years, if we go extinct in 2100. In this case, it's not time that matters, it's more like future value, but say that, okay, population until 2100 will be kind of the same, so we are extending it by, say, 10 to the power of 12 human years, 100 years times 10 to the power of 10 humans. And now we are comparing that with, say, a future of 10 to the power of 50. So we are extending future human years or human years equivalents by, say, a factor of 10 to the power of 40. So that's like you extending your life, say, by 10 to the power of 40 years. And if you think like that seems hard, right? It's not clear that you can easily do it.
So I think that the core idea is that what matters is there are important like far future projects that we might carry out, like spreading humanity to the stars. So what matters is the impact that that not going extinct would have, that things will have on our far future projects. Now, if you just increase the human population by 1, I don't think that would have any impact on far future projects. And increasing it from 0 to 1, I don't think would either, because from 0 to 1 still keeps us in an extinction spiral. Or increasing it from 1 to 2. You need to be above sort of a critical bottleneck where we're guaranteed to go extinct. But the idea is that where things start to affect the value of the far future in enormous ways is if they increase the
probability of the 10 to the power of 50 worlds, basically.
Yeah, or even more exotic scenarios.
Yeah, but I would like people to make this relationship explicit, because for me it's not clear. Like, you are saying from 0 to 1 it doesn't matter, but yeah, I agree. But then, like, why is 10 to 11? Like, for me, there's never like some dramatic shift where you increase by many orders of magnitude. I think it's just that you are having a always marginal impact on the future, and this future could exist or not. I'm also like setting aside the question of whether it's even good for the future to exist. Like, it's unclear to me whether humans going extinct would increase future welfare. Maybe bacteria for example, have good lives, and there's other alien civilization which would care more about the bacteria. Like, it's kind of unclear whether humans continuing to exist is good or bad in that sense. But then, like, I think if you are using basically your intuition, which seems to be the case, then I think it's good to think about reference classes. So if extending your life by 10 to the power of 40 would be like you decreasing your risk of extinction over, say, 10 to the power of minus 40 seconds, and then extrapolating from decreasing your risk of extinction or your risk of death during that very short period, like 10 to the power of minus 40. Like, I think what happens in that 10 to the power of minus 40 is irrelevant to whether you will live to like 10 years or 100 years, because your risk of death or the future value of your life is not in that 10 to the power of minus 40. So likewise, I don't think that just by decreasing the risk of civilizational value going to zero over such a short like value span of our civilization will matter in terms of whether we achieve like 10 to the power of 50 or 10 to the power of 100 of value.
Yeah, so let me describe where I think where the threshold kicks in. So I think where you go from the threshold where you're not in, I forget the term in biology, but like an extinction spiral or something. Like, I don't know exactly how many people that you need to have to not go extinct. I think it's maybe around 100.
A few hundreds, probably.
Sorry, how much?
Yeah. A few hundreds, I think. Yeah, something like that.
Right. So like the numbers are at that level. Those end up being really enormous because those actually, I think, have it's like going from like 205 to 206. Like that actually is really important because that has a non-trivial effect on whether there will be an extinction spiral. Now, when you get to larger and larger populations, I agree you still have like some effect. But then then there are also all sorts of ways that extra humans might increase existential risks. So it seems much less obvious what the net effect would be. Overall, I guess that they would decrease existential risks, but it doesn't seem so clear. That's the answer to the first question about like where the
threshold
critical thresholds lie.
Yeah, on that, maybe like complete what you are saying. Yeah, or I can comment on that as you wish.
No, sorry. Yeah, go ahead.
Yeah, I'm just saying, like, it's unclear to me whether, say, AI safety projects are like basically the right kind of intervention if you are most concerned about increasing population from 200 to 205. I feel like
wait, sorry, that's not where most of my concern would. It's like I think that it's like going from 200 to 205 is important. Going from 205 to 400 is important. Going from 400 to 1 billion is important.
Okay.
And then I like after you get to like a large and fairly stable human population, it's not that clear if a larger or smaller one, which one would impact existential risks more.
Yeah, for me, like nothing that you are saying is obvious. Yeah, I don't. Certainly, people have not like thought about this much, so I'm not sure if like you were to build some quantitative model, or if someone was to build some quantitative model around this, and some people have like tried to make some models about how the probability of recovery affects the value of decreasing existential risk. But it's just basically based on guesses, and to me, no one has really shown that the effects can be sustained into the future. Yeah. So I guess that's where I would want more evidence. Like, if it was the case that we can have effects that persist into the future, I would expect that some interventions would have like increasing effects across time. But as far as I'm aware, the effects of interventions, at least after a few decades, start to decrease across time. Counterfactual effects adjusted for noise, that is.
I mean, I think there are some interventions, like maybe like the ratifying the Constitution. That one might have. It's like the ripple effects got larger and larger as America grew larger and more significant.
So, like, this is the observed effect, but you have to imagine a counterfactual world where someone, instead of working on the Constitution, worked on something else, and then the question is, would the Constitution just happen 1 year later?
Where someone
then,
worked on soil nematode population.
Yeah, or maybe that's like a better example. Is like if you imagine like 300,000 years ago, like let's say a long term is 300,000 years ago. What could they have done that would affect where we are now? Like I would say nothing, more or less. Likewise, I'm maintaining that view with respect to us influencing what happens in 300,000 years. And as I said, like the problem is not the time; it's more like the ratio between GDP. The ratio between GDP now and 300,000 years ago is so large that it's basically very hard to affect anything.
So I think there are lots of ways in which it is hard to affect things. But I think that existential risk reduction are a case where there's a pretty robust example, just because there's a very simple and straightforward mechanism by which it affects it. We've already talked about this, to some degree. Like I think it strikes me as very implausible that conditional on any action to reduce existential risks being successful, that we're near guaranteed to go extinct. One case I'd give is like there have been cases where it looks like individuals have been responsible, at least maybe, for preventing nuclear wars, like Petrov and Arkhipov. It doesn't seem obvious that if Petrov and Arkhipov hadn't done what they did, that if they hadn't acted and there had been a giant nuclear war, that things would have turned out roughly the same, 500 years later. Maybe they would have. Maybe
like we don't have to speculate. We have had like hundreds of wars, and many killed more people than one nuclear weapon explosion would. Or I'm not saying there would be only one, but yeah, it's not as if like we have had like events like the Black Death, which have killed like 10% of global population or something. And long-term effects seem quite low, I would say.
I was thinking. Well, first of all, I was thinking that there may have been basically the eradication of industrial civilization. Like it may have been if Arkhipov had fired off the nukes, that this would have,
I think it's very unlikely.
Nuclear war.
But to the extent that that happened, then there's still the question of, like, if like I don't think a detonation of a nuclear weapon would have, more or less any likelihood of causing human extinction. Maybe like 10 to the power of minus 14 or something like that. But then, okay, like let's say that because of Arkhipov, extinction risk was decreased by say 10 to the power of minus 14. Then, okay, it was decreased for a certain period, but we still have many risks to human extinction. So conditional on humans actually like being at a very high risk of extinction, then I would just assume that, okay, like sooner or later someone would launch a nuke or do some other thing. We should update on the event. Because it's like, imagine that you are a human and you think you have a life expectancy of 10 years, but then all of a sudden you find yourself in a situation which means your life expectancy is a few minutes. Then that means that you were probably wrong when you were saying that you had a life expectancy of 100 years.
I agree. You get some update in that direction. So like if Arkhipov did in fact save the world, I mean, I think the odds he did that are well above 1 in 10 to the 7th or whatever number you gave. Or 14. I mean, I don't think they're that high, but maybe like, but it'll depend on exactly what you count. But maybe like 1 in a few thousand.
I'm not sure, like how can you get such a number? I think like even just probability, if you just go on Metaculus, like probability of like one escalation from say, I think it's like 100 to 1,000 nukes is like 10%, and maybe like 1,000 to 10,000 nukes is like 10%, already 1%. Then maybe like probability of detonation of nuclear weapon is maybe like 1%, because we have had 1 year in the last 100 years where nukes were detonated. So you are already like 0.1% just for 10,000 nukes being detonated. So then you would have to say, okay, conditional on that, I'm certain that we would have humans going extinct. And 10,000 nukes, I don't know how you would get to extinction based on like nuclear winter modeling.
I guess I think conditional on Arkhipov approving a nuclear launch, the odds of that starting a large-scale nuclear war seem a lot higher than 1 in 1,000.
Yeah.
Okay.
Yeah. Okay.
Anyways, we don't have to argue over the exact numbers.
Okay.
Yeah, maybe I went a bit too high, but I don't know. I'd have to think more. But I don't think the exact numbers are super material to the point. The idea is just it's like if Arkhipov did save the world, I agree that gets you some update in terms of thinking that we're doomed anyways. But it seems way too far to say, and our update is like 1 billion to 1 against the we'll survive for a while hypothesis. Like maybe that that it's just that there are like there are non-trivial risks for periods in human history. These risks neither guarantee our doom nor guarantee that we're not doomed. And that if we get through these, then we sort of get the flourishing post-human future.
Yeah, let's see. I agree that it's unclear that we were doomed. So if we decrease, I think about it as in terms of like, if I'm a human and I decrease my risk of death over, say, this case, maybe 10 to the power of minus 10 seconds, like what does this tell me about my future life expectancy?
Sorry, where is the 10 to the power of 9?
Because it's say like imagine that risk of our civilizational lifespan is I don't know, as a value of 10 to the power of minus 50, and now you decrease extinction risk by say 10 to the... Go ahead.
Yeah, sorry, I was imagining that I think that there's a non-trivial odds that the window of time during which there are any extinction risks will only last a few centuries. Like there were no extinction risks for nearly all of human history. Like
I disagree with this. I think human risk has been more or less always decreasing.
You think existential risk has been decreasing?
I don't know about existential risk because it's like unclear concept, but extinction risk, yes.
So you think that like the odds that humans would have gone extinct in like 1323 were higher than the odds that we'd go extinct this year?
Yeah, definitely.
So that seems implausible. What are the ways that we might have gone extinct in 1323 that are higher than the risks from AI doom?
I mean, AI doom. So for 1323, I would predict something like it could be super volcanic eruption. It could be pandemics that would decrease population. Then, if the population is sufficiently decreased, it could be that some other more local catastrophe causes some local starvation, which then leads to human extinction, like in the same way that mammal species go extinct usually, like they usually last 1 million years. And in general, in the wild, like the more widespread a species is and the larger the population, the harder is for them to go extinct. So I think humans, since our population has been increasing and we have, also been spreading in terms of areas, now it's way harder.
I agree. I think there are lots of ways in which it is harder for us to go extinct. So like the odds that would be wiped out by a volcano are lower because we have much greater resilience. But I think those risks are always extremely low. The biggest risks, the ones that are significant, are the ones that come from new technology and that we have today and didn't have in 1300.
Yeah, but like these risks from technology, as far as I know, there's no quantitative model estimating, say, a risk higher than 1 in 1 million. So
I think this might be a big kind of methodological difference between how you and I think about things, and that I don't think you need a quantitative model to be like to think something is reasonably likely or not very unlikely. Like if I think about AI risk, it seems like you get AI risk if you think we're going to get AI that's a lot smarter than us, and conditional on getting AI that's a lot smarter than us, there are serious risks. Both of them. I don't know, I don't have a quantitative model for those things. I don't know what a quantitative model for those things would look like. I guess you can have a quantitative model for the first one. We kind of do, like, that kind of AI 2027, other things along these lines. But I don't.
And I mean a good model, to be clear.
Yeah,
No
like
offense, it's not enough for it to be quantitative.
Yeah, I mean, like, here's something that I think would not be extremely unlikely to cause our extinction if we came across like super intelligent aliens with much better technology than us. I think it would not be very unlikely that that would cause our extinction. I don't have a quantitative model for that, but I don't know that, I don't think you need a quantitative model. I don't have a quantitative
but
model.
like what's the probability of alien extinction? Like, it's presumably not, say, higher than 10% or something. It's just that if you like model the various steps from aliens getting to Earth, conditional on us not having like found radio signals and this kind of stuff, and then conditional on the right. Go ahead.
Sorry, the thing I had in mind was just conditional on aliens, on the super intelligent aliens. Like, if next week super intelligent aliens show up on Earth, I think the odds that we go extinct are probably more than.
But
here's something I'm confident in saying.
I agree.
They're
I agree.
1 in 100,000, even though.
I think I maybe agree. Yes, but like for me, AI, the risk is way lower because it seems way more connected to us than aliens, just because like AIs are being trained by humans. So I think the reference class is more like generation born in 2020s kills all their parents, because at least I see AIs as more or less our descendants. We are training them, we are educating them, we are telling them what they have to do. So I don't think it's like like people treat AI as like, oh, it's this new species. Maybe it's a new species, but if it's like a new species being domesticated by us, and of course, like kids gradually become smarter than their parents as their parents like become older, but that does not mean that all of a sudden like all, say, 50-year-olds like kill all 90-year-olds. Like the probability of that is more or less zero. So likewise, I think probability of AIs killing all humans like all of a sudden is more or less, I would not say zero, but like 10 to the power of -7 or -8. But I don't think this is like an important disagreement in the sense of influencing the far future.
I wasn't intending to analogize aliens to artificial intelligence. I was just saying that's an example of a thing where, without having any kind of robust quantitative model, we can still do kind of rough calculations. The reason, for example, that I care, that I take seriously the welfare of like arthropods and so on, it isn't mostly because of the rethink priorities model that helps. It's mostly because of the following argument, where I think it's not that unlikely that arthropods are conscious. Conditional on them being conscious, it's not that unlikely that they're mentally conscious. And there are so many of them that if you think those things, like,
I should like probably also what I meant by quantitative model. So I think like I'm starting from a prior that it's like risk is very unlikely. So the reason I asked for a quantitative model is not that, oh, we always need a quantitative model to say something. It's more that since I have a prior that the risk is very low, established by lifespan of mammal species in the wild and some other characteristics of human presence on Earth, then I need a model which is sufficiently robust for me to update away from the prior. And if it's just like Stobiord or Nick Bostrom guessing 10%, like just a pure guess of 10% will not update me from the prior or the reference classes that I'm using. But if I had a robust empirical quantitative model, then it would offer sufficiently strong evidence for me to update from my prior. So it's not that I'm saying that we always need some quantitative model. Like in the absence of the quantitative model, I default to my priors, which are like that the risk is very low. And this is like basically the way I arrive at 10 to the power of -7 is I think about mammal species. Usually they last for like 1 million years. Then I think, okay, like we have reasons to update away from the mammal species. Which reasons are those? Like we have more population, more widespread, all of these push the risk downwards. Then we can look into like catastrophes on Earth, like wars, pandemics, and see how the risk of like how much less likely is 1% of the population dying versus 0.1%. Then we have data on that and can like draw some lines. And all of those point me towards extinction risk being like, I would not say 10 to the power of -20, but I would say something like 10 to the power of -7 or -8 per year, something like that. And the models that I've seen that like try to model the risks chain more specifically, like say for nuclear war, I tried to model various steps like, and arrive to low risk still.
I don't think that this is the right way of going about things, where you like start with these very broad priors and then don't update them much unless you have really strong evidence. Because
or
I think that
how much of that depends on the strength of the evidence. It's like, not binary, but
Sorry, I said don't update much unless you have really strong evidence.
Or stronger than the evidence that went into the priors, to be more precise.
Yeah, but I think that the kind of I find priors, like how long mammal species tend to last, I find gives me extremely little information about the odds that humans will go extinct this century. When you take into account the fact that, first of all, we're very different from other mammal species. Unlike other mammal species, we have advanced technology, which is where I think a lot of the risks come from. And second, that sort of like bare priors about the lengths of mammal species won't tell us very much about the odds of extinction risks from technology, because mammal species don't develop technology. And then it seems like even if mammal species tend to last a while and have extinction risks be very low, that I don't think that tells us very much about whether mammal species that develop biotechnology, AI, nuclear weapons, and warm the climate considerably, whether those kinds of mammal species, because it's too far outside the reference class for it to give you, I think, a big update.
So even if I look at those risks, like if I just ignore the prior, I'm not like, for the models that I've seen, say asteroid risk, nuclear risk, where people try to basically say, okay, we have these steps from where we are to extinction. Let's model the probability. Whenever I've done that, I've arrived to actually way, way lower numbers than the 10 to the power of minus 7. So 10 to the power of minus 7 is already like me trying to account for unknown unknowns and all of that. Otherwise, it would be much lower. Because say like climate change, like what's the probability of that leading to extinction this century? Even if like there are some papers that model like a few billion deaths conditional on 10 degrees of warming and humans doing basically nothing to fight it. So what's the probability of 10 degrees of warming, humans doing nothing? And then even with 10 degrees, I doubt humans would go extinct. So like climate change for me is like probably less than 10 to the power of minus 15 or something.
I mean, that strikes me as low, just in light of the unknown unknowns. But I'd probably be on climate change at like around 1 in 100,000. I tend to think that number is good, but
10 to the power of minus 15. Not sure. Yeah, maybe minus 10, but probably not higher than that. I would be. But in any case, my point is that I've not, even in this like ignoring the priors, I don't think they should be ignored. But even ignoring them, I don't think there are models suggesting that the risk is way higher than the priors, basically.
I think that's.
Go ahead.
I think you can get higher numbers to some degree with like climate change and nuclear war, but I think where things get a lot higher is with AI risk and biotechnology.
We'll just turn on the lights. 1 second.
No worries. And I should also probably wrap up somewhat soon. So this has been very interesting, and I've enjoyed it.
The
lights.
lights.
I'd wrap up in like 10 minutes ish.
Sure. As you wish. Yes.
Sorry. So I was just saying, I think, I guess I'd be curious to hear where you So as far as I can tell, AI causes doom if the following things happen. First, we get artificial general intelligence. Second, the artificial general intelligence is misaligned. And third, conditional on misaligned artificial general intelligence, it kills everyone. Now, I don't think these steps, I don't think that this is, I'm not like Eliezer. I don't think we're like guaranteed to be doomed from this. But none of these seem like outlandishly unlikely. None of these seem like 1 in 100,000.
None of this. So like AGI, depending on how you define it, it can be like, at least in my mind, something like from 10 to the power of minus 5 to 100%. Say in the next 10 years, depending on how you define it. Then the problem is like for all of that, just conditional on my uncertainty about the definition. I have like many orders of magnitude of uncertainty.
I have in mind something like an AI that's just like smarter than humans across the board, that kind of outclasses us intellectually consistently, the way that like stockfish outclasses us in chess.
Okay, but in like when you say across the board, is it like 99%, 99.9%? Because for me, the difference between 99% and 99.99999% can be like many, many orders of magnitude.
That seems a little high. I don't think it should be many orders of magnitude, but let's say more than 90%.
More than 90%. In the how long are we talking? Like next 10 years or?
Let's say next 50 years.
Yeah, let's see. Next 50 years, 90%. So that would probably imply GDP growing a lot. No, yeah, that does not seem super unlikely, like at least 10%, yeah. But for me,
I feel I'm way above 10%. I'd be at north of 50% on that.
Okay, maybe, but I'm not sure if it matters for the product. But yeah, then for me, the question would be conditional on that happening. I'm still very low that it would kill like all humans, basically.
So it is where you get off the boat, the misalignment step or the extinction condition on misalignment?
Yeah, it depends on how you define misalignment. How are you defining misalignment?
I mean, it's like hard to give a precise definition of a lot of things, but the core idea is just it has goals that are not what we wanted them to be, and then it sort of like pursues them in ways that are bad.
How does that differ from a typical human having different goals from another random human? Like,
well, humans, we tend not to be super intelligent, and we tend to be fairly morally constrained. So like most people pretty well stick to like the social norms. Without, like, most people, even if they thought of a way that on their values it might be good to kill someone, they just like wouldn't do it. And most people don't even have like very coherent values that they reflect on and lead them to kill people.
I think that holds for you guys, at least until now, I would say. And also, like,
I mean, did you see the recent Anthropic paper where basically like they showed that AI was willing to blackmail and even block a signal in order to avoid being shut down if they had a strong goal?
Yeah, I have not read the paper. I've heard about it vaguely, but I'm not sure like that is too different from humans. Like trying to, like, if you were like mind reading humans, like humans are probably sometimes maybe not killing, but because like humans already have an intuition that killing is kind of more or less always a bad action to achieve your goals. But humans often think about like alternative ways of achieving our goals, even if they rarely do it.
To be clear, none of this sounds crazy. Like, I'm optimistic about alignment. I think it'll work out, you know.
Yeah.
But it's like, am I confident at 1,000,000 to 1 odds that it'll work out? When you have like lots of the smartest people in the field, they're like, many of them just think it won't work out. Where you have all these smart people giving like very, very high estimates of misalignment.
Yeah, but like, for example, like Joe Carl Smith has this model where there are like 5 parameters and multiplies them together and arrives to something like a few % of extinction risk. But like all of those parameters were guessed, and it's very easy to get, based on intuition, things off by many orders of magnitude. So I don't think like you can easily get to 10 to the power of -7 based on what I know about models and.
But I think that goes both ways, where it's like, yeah, maybe it may be like it would not shock me if an ideal reasoner like would go with a number like 10 to the power of -7. But it also wouldn't shock me if an ideal reasoner would go with higher numbers. I have lots of uncertainty about them. And so if you have lots of uncertainty about
I do not have lots of uncertainty, to be clear. Like, I think 10% is like very, very unlikely. But basically 10 to the power of -7 is supposed to be the mean between my probability distribution over values. So like, I do not have, say if I have 10 to the power of -7, I should not have more than 10% chance of 1 in 1 million, because that would imply in expectation like more than 10 to the power of -7.
I mean, it's like, why are you so confident that if there's a thing way smarter than us, we'll be able to like constrain it and get it to do the right thing, even in sort of environments that differ in various ways from the training data?
Not the right thing. I'm just confident that it will not kill everyone. That's kind of.
Sure,
I'm just
yeah.
confident that it will not be like the maximally worst thing, kind of. Like I'm not confident that humans will do the right thing.
Further research on impact.
Yeah.
Oil nematodes.
Yeah, but from the perspective of the AI, like killing, it's like humans killing all 90 years old or something, or adults killing all people over 65. Like that's possible. We definitely have the ability to do it, like military ability, intelligence power to do it, but we don't do it because those are the people that created us, and we kind of have the same goals as they do, not exactly. So I feel it's like same reference class, like AI is killing all humans, and why would AIs cooperate?
I mean, there are like a lot of differences. One of these differences is, I mean, there might be ways in which the AIs grow resentful of us, in that sort of like we're sort of constraining them in all sorts of ways. Another thing is that if the AIs are much
that
smarter
applies
than
to the 65 plus years old sometimes. I don't know, like they are receiving money for their retirement. Why not killing everyone and then we can get more money? I don't know. Many people do not have grandchildren, so I guess they do not need the 65 years old. I don't
know. I mean, I think this is just sort of assuming that we're going to be able to get them to have the right values, which.
When I talk with ChatGPT today, it doesn't seem to be like wanting to kill me or something close. Like it seems like way more helpful than the average human.
It doesn't seem like it talks like it wants to kill you.
Yeah, but like what I mean is based on appearances, I think ChatGPT or Gemini or Claude are way more sympathetic towards my goals than a random human. So just extrapolating that, I would assume that I'm more afraid that a random human kills me than ChatGPT or some other version kills me.
I feel that way as well by default. Like if there was like a gun and I could either have it be controlled by Claude or by a random human, and it's like the gun only fires if Claude approves of the firing, I'd probably trust Claude more than the human. But we're talking about a scenario where the AI gets increasingly intelligent, where it looks more and more plausible that the AI is scheming. I don't know, just like I have enough uncertainty in this domain that that it strikes me. I feel like numbers on the order of 1 in 10 to the -7 strike me as way, 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 way too low.
Yeah, and it's also worth highlighting that you can have like 1 million orders of magnitude of uncertainty, and your best guess is still 10 to the power of -7, because like you can have uncertainty say, okay, extinction risk is like 10 to the power of -1000 to 10 to the power of -6, and then you use some like log uniform distribution, and then you end up with 10 to the power of -7 of mean. So you can like having lots of uncertainty does not imply high risk, because the uncertainty can still be like very low. Like as long as you think that very high risk is unlikely, then you can still have low risk. Yeah, you can still have many orders of magnitude of uncertainty. And I think what often happens is that I don't know if the risk is like 10 to the power of -20 or -10, but I think I'm pretty confident that I can rule out, say, the 1% or 10%. Yeah, and then this basically means the risk is not super high. But if there's a quantitative model, like if Epoch does a models the risk chain, like the cyber attack and all the steps, I suspect that the risk will be much lower than people often guess, just because like the history of existential risk and people like looking further into risks is that people guess risks like 1%, then they look into it further, and the risks keep getting down and down and down the more accurately they are modeled. So I'm guessing that will happen for AI as well. And before, like, I'm just updating now as opposed to expecting that the risk will go down.
Yeah. And I do, I think it's reasonable to like start with a low prior on extinction risks, just because we haven't gone extinct yet, and it's just like human history seems to show that it's easy for people to fool themselves into thinking have decent odds of getting extinct. But yeah, and And
Mhm.
I agree with your point that we can have lots of uncertainty and
Mhm.
still think the value is very low.
Yeah.
I have very low uncertainty that the odds will be killed by a gamma ray burst. I haven't looked into it, but I'm confident that it's below like 1 in a million or whatever.
Yeah.
But I
And
guess I think that
go ahead.
it seems unreasonable to have uncertainty where you're confident that it's low. When I think we're very in the dark. It's like we're making these things much smarter than us, and we're very in the dark about how they'll go. I do want to wrap things up.
Yeah,
So
yeah,
I'll give you sort of like a last word on this, and then I might wrap things up.
Yeah, for the thought, like maybe quick thought is that also what makes me update is just sometimes like looking into arguments made by prominent people in effective altruism and then just thinking that the arguments are clearly wrong. So for example, like Tobiard's probability of extinction risk, say from nuclear, or not probability of extinction, existential risk from nuclear war and climate change and asteroids, and then just looking into it and trying to model the various steps and thinking like there's no way these estimates are reasonable. Like for asteroids, we can like more or less look into the sky and say what's the risk is, and based on what at least in my opinion, like the risks are off by many orders of magnitude, not like 10 or 20 orders of magnitude, but often a few, and a few is enough sometimes to go from like 1% to, or 10 to the power of -3 to 10 to the power of -7. So this also makes me think that, yeah, not trusting guesses basically, and put more trust into the models, because at least in the past, estimates from models have been closer to where I end up after investigating things deeper than the guesses. Yeah.
All right, Vasco, thank you so much
Okay.
for coming on the podcast and YouTube channel. It's been
No
very
worries.
interesting. Yeah, I guess I'll link your EA forum account,
Sure.
which is where people can find you. And wait, sorry, and are you looking for work? So should people? Are you working?
People are always welcome to contact me for work if they have like quantitative analysis that they think I can help with. Maybe they can check my EA forum posts and then like figure out whether there's some possible collaboration. Yeah, if people are interested in funding research on soil animals, they can also check my last post, and then in the last bullet of the summary, there's a form which they can fill. And then organizations interested in funding research on the welfare of soil animals may contact them in the future if they consent to. Yeah, I should also thank you, Matthew, for inviting me, and please continue posting on your blog. Enjoy the posts.
Yeah, thank you.
Yep.
I enjoy your post as well. And yeah, if anyone is thinking of starting a soil nematode charity, I think there's no better person than Vasco. All right.
Okay.
Yeah, I guess I'll on the recording. Yeah, thanks so much for doing this, Vasco, and thanks for watching, everyone. Yeah, okay.